Okay, yeah, let's get to stoichiometry now. So guys, you remember from grade 11 that when we talked about stoichiometry, we talked about the ratios or the relationship between two compounds that we are going to form a reaction with. Okay, so now this type of reaction is an acid base type of reaction, so I'm talking about neutralization. Okay, so now before I can do anything, before I can talk about stoichiometry, what must I do? I must first check if my equation is balanced. Okay, so if I can check the equation, I have two hydrogens on the left, I have two hydrogens on the right. Okay, one is one Cl on the left, one Cl on the right, one sodium on the left, one sodium on the right. Okay, oxygens, I have one on the left, one on the right, so everything is balanced. Okay guys, so this equation is balanced, so it is safe for me to check stoichiometric ratios. Okay, so now when the equation is balanced like this, what am I going to check? I'm going to check the numbers before my compounds. Okay, so these numbers are called stoichiometric ratios, uh, not ratios, I'm sorry, stoichiometric coefficients. Yes, stoichiometric coefficients. So here there's one, here there's one, one, one. Okay, so they are called what? Stoichiometric coefficient. Okay, so they're the values that we are going to use in ratio. So what happens here is that I can see that for every mole of the HCl, 1 mole of sodium hydroxide is required. Okay, so alternatively, in other notation, we can write that 1 n for moles, 1 mole of HCl requires 1 mole of sodium hydroxide to complete the reaction, so that everything will be neutral. You see, so meaning 1 mole of hydrochloric acid requires 1 mole of sodium hydroxide to neutralize it. Okay, so now let's go to the question and answer the question. Okay, so here's the statement. It was found that 0,0153 moles per dm cubed of HCl of volume 23.0 cubic centimeters was neutralized by 17.6 cubic centimeters of sodium hydroxide. Calculate the concentration of sodium hydroxide. Okay, so first things first, we have to check the statement and check the data that they have given us. Okay, so if you can check, we were given okay, let me write solution here. Okay, so if you can check, we are given the concentration of hydrochloric acid, so it's 0,0153 mole per decimeter cubed. What else are we given? We are given the volume of the HCl as well, is 22,30 cubic centimeters. Okay, so we're also given another set of information. We are given what? We are given sodium hydroxide. Okay, so we are given the volume of sodium hydroxide, so which is 17,60 cubic centimeters of sodium hydroxide. Okay, so here HCl. Okay, HCl. So now we have concentration, we have volume, we have volume. So let me write the notations and say this is concentration of the acid. Let me write it Ca, and this is volume of the acid, Va. Okay, so here let me say this is volume of the base and write Vb. Okay, so now we are going to do this calculation the old style. Okay, that's why I'm back to stoichiometry, back to revision. Okay, so what am I going to do is this. Remember, I've showed you on this video that we can calculate the number of moles from concentration and volume. Okay, so now first of all we have to know the number of moles of HCl. Okay, and then we can calculate how many or how much moles of sodium hydroxide are needed to neutralize that amount of moles available in this solution. Okay, so we are going to do this now. Moles of acid are given by concentration of acid multiplied by volume of the acid. Okay, so now how much is our concentration? Our concentration is 0,0153 mole per decimeter cube. Okay, what about the volume? The volume, it is given in cubic centimeters, and we want a volume with the units of dm cube so that dm cube can cancel this per dm cubed. Okay, so meaning we have to divide this 22.30 by what? By 1000. Okay, so 22.30 divided by 1000. So now it will give us the units of what? Of dm cubed when we've divided it by 1000. Okay, so now how much moles are we getting? 0,0153 multiplied by 22.3 divided by 1000. Okay, so I am getting on my calculator, I'm getting 3.412. Okay, let me take up to 4 significant figures. Okay, because I'm still on intermediate step. 3.412 times 10 exponent -4. Okay, so moles, the units are moles because this dm cubed will cancel this one. Okay, so moles, now the moles of what? Of the acid. The acid is HCl. Okay, so now that I have the moles of the acid, I want to know the relationship between the moles of the acid and the moles of the base. So now the relationship between moles of acid and moles of base is this one. So HCl here and then sodium hydroxide here, right? So I have a ratio 1 mole and 1 mole, you see. So and then now I have moles of HCl. I have 3.412 times 10 to the power -4. Then here I have what? I have X, you see, because I don't know this mole. So you notice because stoichiometry is 1:1, so even if I cross multiply here, X will multiply 1, I'll have X times 1, X times 1, okay, is equals to 1 multiplied by 3,41 times 10 exponent -4. You see, moles of HCl. So now, so X is equals to 3,41 times 10 to the power minus 412. I should have wrote everything, but yeah, I'm saying to the power minus 4 mole of HCl. So you can notice that the number of moles of the acid are equal to moles of the base. right? So O, and here now I will no longer have HCl. I will have moles of what? Of the base, okay? Because I'm trying to get the number of moles of the base, okay, guys, of the base of sodium hydroxide, right? Sodium hydroxide. So I conclude, I say, now moles of sodium hydroxide, they are 0.41 10 to the power minus 4 moles, okay? So now, what is the question saying? The question requires the concentration of sodium hydroxide. So concentration of sodium hydroxide, we'll have to use this formula. Concentration is equals to number of moles divided by volume. So how much moles? 0.41 moles divided by what volume? Divided by 17.60. So that 17.60, we are converting it. Divide 17.60 by 1000, we get 0.0176, okay, as our volume. dm here we have, there's another mistake here. Okay, times 10 exponent minus 4 moles, okay, and then here dm cube. So now if I press my calculator, what am I going to have? 0.41 exponent minus 4 divided by 0.0176. Okay, so I'm going to have 0.0194 moles of what? Of no, mole per dm cubed, right? Mole per dm cubed of sodium hydroxide. So remember, this is Cb, okay? So Cb is equals to Nb divided by Vb, okay? So now this is the concentration of what? Of sodium hydroxide. Okay, guys, this is how we calculate it. Alternatively, we can use this formula: number of moles over moles of acid over moles of base is equals to concentration of acid over uh, concentration of acid times volume of acid divided by concentration of base times volume of base. Okay, so now what is going to happen here? On the Na and the Nb, we are going to put the stoichiometric ratio. Okay, so now Na is the stoichiometric ratio of HCl. It's 1. Okay, so we are going to say 1 over, also for B is 1. Remember, here is 1 is to 1. Okay, it's 1. Okay, so concentration of the acid, we are given concentration of the acid is 0.0153. So we're going to write it there, 0.0153. Okay, multiplied by volume of the acid. So the volume of the acid is what? 22.30. Yes. So now you can go ahead and convert it to dm cube. Okay, it's a good practice for you to convert it to dm cube. Okay, or you can just leave it like that, because you're going to have volume on the numerator and volume at the denominator, and then those units are going to cancel out. But just keep a good practice and convert your volume all the time. So 22.3 divided by 1000, we get that. Okay, so now concentration of the base is what we are looking for. Remember, multiplied by what? Volume of the base. You see, volume of the base, we are given that is 17.60. Okay, because we have converted the top, we will also convert the bottom. Okay guys, 17.60. okay, so we are going to get 0.0176. okay, so you will notice that our variable is CB, so we can cross multiply. When we cross multiply, this is going to be what? CB is equal to 0.0153 times that volume, 0.0223 divided by 0.0176. so what will be CB? So 0.0153 times 0.0223 divided by 0.0176. okay, so now the concentration I'm given is 0.0194 moles per decimeter cubed. So you see now this concentration is the same as that one, you see, but the amount of work it's less, you see. So with using this this formula, we were able to do less amount of work. Okay, but this formula does not really tell us that a learner understands what they are doing. Okay, so because it's just plug and play. So at times, you know, we appreciate that learners will answer the questions like this. Okay, and then it shows that they understand. Okay guys, let's go to our next question. So now here we have another equation. So if we can check this, we have sulfuric acid reacting with what? With potassium hydroxide to form potassium sulfate and water. Okay, so we can see that, oh, this is, we have an acid here, we have a base here. Okay, so now we are given data. We say 2 grams of potassium hydroxide was dissolved in 250 volumetric flask. Okay, so now if 25 cubic centimeters of the prepared solution of KOH was neutralized with 22.30 of sulfuric acid, calculate the concentration of the sulfuric acid. Okay, so now what are we going to do? First of all, we have to know the concentration of the potassium hydroxide, right? The concentration of this solution, right? And we know that per volume that concentration will remain the same as long as we are not going to dilute that solution. Okay, so now first things first, you have to calculate the concentration, right? I've told you how to calculate concentration. Okay, so now concentration is given by what? Mass, given mass divided by molar mass times what? Times volume. Okay, so now this volume, we are given that the volume is 250 cubic centimeters. So when we convert this volume, it's going to give us what? It's going to give us 0.25 decimeter cube. Okay, so we are going to divide this 250 by what? By 1000. Okay, so now we are given the mass. We have to find the molar mass of potassium hydroxide. So what is the molar mass of potassium. Here, okay, let me try to zoom it. I can see that it's what is 39. Okay, 39.0. So now the molar mass of what of KOH, okay, is what I have 39 plus plus 16 for oxygen plus 1 for hydrogen. So how much is my molar mass? I have 56 grams per mole, okay, or of molar mass. So I'm going to take that molar mass and substitute it here. So now the smaller m is the given mass, which is the 2 grams. So I'm going to say 2 gram divided by molar mass 56 multiplied by the volume. What is the volume? The volume is 0.25. Okay, so if you press your calculator now, you get 2 divided by 56 times 0.25. So how much are you getting? The concentration getting 0.143 mole per decimeter cubed of what? Remember, we are calculating concentration of KOH. Okay, so this is the concentration of KOH, right? So now this concentration, now it is per volume. So even in 25 cubic centimeters, the concentration is still the same. Okay, so now we want the number of moles of the base, right? The KOH in what? In 25 cubic centimeters. So for us to get number of moles, we must say concentration of the base multiplied by volume of the base. Okay, so volume of the base is what is 25 cubic centimeters, then concentration is what we have calculated just now. Okay, so we will do this. We will say 0.143 multiplied by 25. That 25 we are going to divide it by 1000. Okay, so 0.025. Okay, so now go on and multiply out this 0.143 times 0.025. Okay, so how much are we getting? Getting 3.5 575 times 10 to the power minus 3 moles of what? Moles of the base, moles of KOH. Okay, so now that I have the moles of KOH, I want to know the moles of sulfuric acid so that I can calculate its concentration. Okay, so now what do I know with the sulfuric acid? I know that the volume of sulfuric acid is 22.3, right? So now I want to know the moles of sulfuric acid. So I have to go back to stoichiometry. Okay, so I have 1:2. Okay, so here I have H2SO4. So I have H2SO4 and I have what? I have KOH. Now what is the stoichiometry? This one I have 1 here and then I have 2 in here. Okay, so what moles am I having? I'm having the moles of KOH, so I'm going to put this value here, okay, next to the 2. 3.575 times 10 exponent negative 3, okay, and then in here I put x because it's what I'm trying to calculate, okay. So now what am I going to do? I'm going to cross multiply this x multiplied by that 2, and then this value multiplied by 1, okay. So now I'm going to have 1 multiplied by 3.575 times 10 exponent negative 3 is equals to 2x, isn't it? Is equals to 2x. So now if I can, because I'm looking for x and not 2x, so if I want to solve for x, I'm going to have to divide both sides by x, right? By 2, I'm sorry, I'm going to have to divide both sides by 2. Okay, so divide by 2, divide by 2. So here 2 into 2 goes once, 2 into 2 goes once, okay. So I'm left with x. So now there I have 3.575 times 10 exponent negative 3 divided by 2, okay. So now the moles, I have 1,787, okay, 788. Let's take that one because it's our intermediate answer, okay. Let's not round it off to 2 decimal places yet. So now what is this x? So remember, this x is moles of sulfuric acid. So now the moles of sulfuric acid that are being neutralized by that solution of sodium hydroxide in 25 cubic centimeters will be 1.788 times 10 to the power minus 3 moles, right, of H2SO4. So now we want to calculate the concentration of H2SO4. So what are we going to do? We are going to say the concentration is given by moles over volume, okay. So now the number of moles, 1.788 times 10 exponent negative 3, okay, divided by the volume. Which volume are we going to use? We are going to use 22.3, okay. So 22.3, we convert it to decimeter cubes, okay, because right now it's in cubic centimeters, so we convert it to cubic decimeters. So now it becomes 0.0223, okay. So now when I punch the whole thing, 1.788 times 10 to the power minus 3 divided by 0.0223, what am I getting? I am getting 0.08 0.80, right? So meaning I can leave it there, okay. 0.80 mole per decimeter cube, okay. So that is the concentration of what? Of H2SO4. So we have determined the concentration of H2SO4, okay. So alternatively we can also use that neutralization formula, okay. You can also use that neutralization formula after we have found the concentration of the base and the volume of the base, and now we have what? We have volume of the acid. We can calculate the concentration of the acid. So now we can also use this Na over Nb is equals to Ca Va over Cb Vb, okay. So Na being stoichiometric coefficient of acid, Nb being stoichiometric coefficient of base, okay. Then Ca stoichiometric coefficient of acid, this one volume of acid, concentration of base, volume of base, okay. So let's go back to our equation. So which one is our acid? Our acid is sulfuric acid, okay. So the coefficient is 1, so we are going to write 1 here, okay, divide by, and then on the KOH the coefficient is 2, so we are going to write 2, okay. So Ca is the concentration of what, of the acid. So we were not given the concentration right away, right? We were required to calculate it. So this is the concentration here, weight, and its concentration of base, né? You can't put it on Ca, okay. So Ca is what we are looking for. Its concentration of sulfuric acid is what we have calculated at the end, multiplied by volume of the acid, okay. It's 22.3. okay. So in the previous example I've converted the volume first before I put it here, right? And what did I say? I say keep a good practice of converting your volumes, okay. But even if you don't convert, in this case nothing's going to happen. So if I say 22.30, right, cubic centimeters, let me write it there, divided by now concentration of base, okay. Concentration of base is what I've calculated, okay, 0,143 mole per decimeter cube, okay. So now multiplied by what, the volume of the base, it's 25 cubic centimeters, okay. So you will notice that the cubic centimeter will cancel cubic centimeter, you see. So even if I don't convert the volume, I won't have a problem, because I will be left with the units of mole per dm cubed, you see. So now let's do our maths, guys. So check this. So here I have a value that I want to solve at the top, okay. So what can I do? I can multiply by the reciprocal of this fraction, okay, both sides. So meaning if I multiply both sides, what I multiply on the right hand side will remove this one, and I will be left with Ca, and on the left I will have 0,143 mole per dm cubed, okay, multiply by this one. So divided by 22,30, okay, multiplied by 1/2, isn't it? So is equals to Ca, okay. So let's punch our calculator and see what are we going to have. 0,143 divided by 22.3. Oh, we forgot 25. Okay, we forgot 25 times 25. We forgot 25. Okay, so times that 25 cubic centimeters, okay. So times 25. Okay, so what am I getting? I am getting Ca is equal to 0,080, okay, mole per decimeter cube. So you see this value is the same as what, is the same as this one, okay, but the working here, it's not a lot, okay. But here the working, I don't count this one, because even if you will do this one, you have to do this one. So I'm counting from here, okay, going down. So this is grade 11 method, okay, going down, okay. So this is how we do things, guys. I've used stoichiometry in neutralization reactions. Okay, so I just wanted to remind you stoichiometry. So in the next video I will focus more on titration, so I will be very fast and brief. I'll even do questions. Okay, so now let's go to the last part of it. Okay, this one they always ask about this question. Okay, they love to ask about percentage purity and impurity. So now we are given a balanced equation there. It's a hydrochloric acid reacting with calcium carbonate, okay, to give us calcium chloride plus carbon dioxide plus water. So if you can check, the equation is balanced. Okay, the equation is balanced. Okay, why do I say it's balanced? Because I have 2Cl, 2Cl, one calcium, one calcium, two hydrogens, two hydrogens, three oxygens, three oxygens, one carbon, one carbon. So it is balanced, you see. So now let's go to our statement. So the statement reads as follows: a group of learners from Kopa Secondary want to determine the percent purity of calcium carbonate, okay, in a 1.6 gram of impure sample of calcium carbonate. Okay, so these learners now they have an impure sample which is 1.6 gram. Okay, so in that impure sample there's some percentage of pure calcium carbonate inside that impure sample. Okay, so it means that this calcium carbonate plus some impurities. Okay, so and then they dissolve the whole sample into 24 cubic centimeter solution of hydrochloric acid with concentration 1 mole per dm cubed, right? So calculate the number of mole. Okay, yeah, that's the question. So now what happens before I go to the question? So what they're doing here, they have 20, is it what, 24? Okay, 24 cubic centimeters of what, of HCl of concentration 0 of concentration 1 mole per decimeter cube. Okay, so this is HCl. So they are dissolving the calcium carbonate into this solution. Okay, so assuming that now this calcium carbonate dissolves all of it, this impure dissolves inside this solution, right? So now the pure calcium carbonate will react with this HCl, completely reacts with this HCl. So calculate the number of moles of HCl in 24 cubic centimeter solution. Okay, so as I've showed you how to calculate number of moles of acid or base from known volume and concentration, right? So what are we going to do? Number one, okay, moles of acid. So given by what? Concentration of acid multiplied by volume of acid. So concentration of acid is 1 mole per decimeter cube, isn't it? And then volume of acid is 24 cubic centimeters. So we have to divide that 24 by 1000, okay, to make it to be cubic, to be this cubic decimeters. Okay, so it's going to be 0,024 decimeter cube, you see. So now decimeter per decimeter cubed cancel out with decimeter cubed, and then we are left with moles, you see. So the moles will be 0,024 moles of what? Of the acid, moles of HCl, isn't it? That is number one. Number two, calculate the amount of calcium carbonate that has reacted with HCl, assuming the impure sample has fully dissolved in HCl. Okay. So now, and let's also assume that the HCl is was used up, was completely used up by the calcium carbonate in it. Okay, so assuming the pure sample has reacted to completion with the HCl, okay, and then what was left was the impure stuff. So now they want us to calculate the moles of calcium carbonate. So when they say amount, they want the moles of calcium carbonate. Okay, so now we cannot directly calculate moles of calcium carbonate from this given mass of 1.6 gram because this mass is impure. It's not pure calcium carbonate. Okay, so we have to check the moles that reacted with HCl. Okay, so how are we going to get the moles of calcium carbonate that reacted with HCl? We are going to use a stoichiometric relationship. Okay, guys, so now what is the relationship? We can see that 2 moles of HCl is reacting with 1 mole of calcium carbonate, we get neutralization. Okay, so now for 2 mole of HCl, okay, ratio is 2 mole of HCl is to what? 1 mole of what? Of calcium carbonate, isn't it? So now if you check here, what I've written here is what is the ratio 2:1, isn't it? Okay, so we have the moles of the acid, which is 0,024, right? And then here we have x. Okay, so if you cross multiply, we have what? We have 2x is equals to 1 multiplied by 0,024, isn't it? So now if we divide both sides by 2, here I'm going to have 0,024 divided by 2, which is now 0,012. Okay, 0,012 moles of what? Of calcium carbonate. Okay, so now moles of calcium carbonate, they are 0,012 moles of calcium carbonate. Okay, so we have the moles of calcium carbonate now, so we can calculate the mass of calcium carbonate because we have the moles. So we can calculate the molar mass of calcium carbonate. How are we going to do that? We go to our periodic table, we are going to check calcium. Calcium is 40, okay, and carbon is 12, oxygen is 16. Yes, so let's do this now. When we add everything, we have what? We have calcium, we have 40 plus 12 plus 16 times 3. Okay, so when you press your calculator, I think you should get 100. Yes, we are getting molar mass of 100 grams per mole of calcium carbonate. Okay, so now we are going to use the famous formula from grade 11, from previous grades, from grade 10, given mass over molar mass. Okay, given mass over molar mass. So now what we want mass, we want the given mass. Okay, so meaning now if I make m smaller m subject of the formula, I will cross multiply, I will have moles multiplied by what? The molar mass. Okay, so now the moles, they are 0,012 multiplied by 100. Okay, so 0,012 times 100, I'm getting 1.2 grams, or 1.2 grams of what? Of calcium carbonate. Now this is pure calcium carbonate, guys. This is pure calcium carbonate. And now, which question are we answering? Oh, we've went about. Okay, so the question only required the amount of calcium carbonate, guys. Okay, so so question 2 ends here. Question 2 ends here. Okay, it ends here. Question 2, that the remarks ends here. So now this is what is question 3. It's actually question 3, whereby they say calculate the percent purity of calcium carbonate in the impure sample. So in order for us to calculate percentage impurity, we are going to need mass of the pure sample and divide it by the mass of the impure sample, okay, and multiply by 100. Okay, that is why here I have calculated mass. Okay, so in order for us to get mass, we knew the moles, we knew the molar mass. Okay, so now the given mass, here we have the given mass. Okay, so now percentage purity is given by the pure sample, mass of the pure sample, divided by the impure sample. Okay, multiplied by what? Multiplied by 100. Okay, so now the pure sample, I have 1.2 gram. Okay, and then the impure 1.6 gram, multiplied by 100. Okay, guys, so now 1.2 divided by 1.6 times 100. Okay, so 75%. Okay, so meaning that the sample contains 75% of calcium, of pure calcium carbonate, and the other 25% is just impurities. Okay, so this is how we calculate percent impurity. Okay, percent purity, I'm sorry, percent purity. Okay, so now from this, if they can ask you calculate percent impurity, what are you going to do? So you are going to say impure so percent impurity, so we are going to say impure stuff. The impure stuff is equals to the total sample, the sample minus what? Calcium, pure calcium carbonate. Okay, so now this sample, the mass of this sample is 1.6 gram. Okay, 1.6 gram minus pure calcium carbonate 1.2 gram. So 1.6 minus 1.2, you have 0.4. You have 0.4 grams of the other stuff, of impure stuff. Okay, of impurities. Okay, of impurities. Okay, so now, meaning if you calculate percentage impurity, okay, let me write it here. Percentage impurity, we are going to have 0.4 gram divided by 1.6 gram times 100. Okay, 0.4 divided by 1.6 times 100, we have what? 25% of impurities in our total sample. You see, so this is what they want. Okay, guys, so I hope you have enjoyed the lesson, and I have been very patient and slow paced because I understand that many learners, they struggle with this. So okay guys, keep well. The next video will be on titrations, back titrations and neutralization titration. So some of the titration calculations, I've covered them in this video. Okay guys, thank you. Ciao.